Now we come to the third product that we spoke about, which is Lighthouse. So what it does is it's a built into Chrome tool that audits your page in 30 seconds across 5 categories. So it audits the accessibility, performance, best practices, SEO, and PWA. So accessibility score is between 0 to 10, tests 30 plus rules from AXScore engine, weighted scoring based on severity. Why it's powerful? So it's no installation needed, built into Chrome DevTools, creates competitive pressure, right? So our score is 68, competitor is 91, and a lot of benchmarking in GIGW or ACTS are also placed around that. If the score is 90 above, then it is considered reasonably accessible and all of those things. Integrates with CI/CD pipelines. Lighthouse CI can block bad deployments also. The cache only tests the initial page load, so misses on a lot of dynamic content. If your website or your app carries a lot of dynamic content, maybe this tool is not the best for you. So the first step in every accessibility audit can be this, because it just gives you a good starting point. Just with the score, you'll be able to kind of understand that, okay, I need to work at least this much to achieve a score which is above 90-95, and that is the good score. If I am somewhere around 60, then I should use all the tools available in the market in order to get to the core of all the accessibility issues. But am I better than the wave tool? That we'll come to. So how it is basically doing that testing and labeling is like, it gives you these scores. It's a nice dashboard, and under each you can kind of get an idea. So it tells you about performance metrics. So first, contentful paint, so initial content visibility, speed index, visual load speed, largest contentful paint, main content loads, and total blocking time, so page responsiveness and everything, and visual stability, so like cumulative layout, right? So all of these are important points. Accessibility checks it is able to do is, color contrast ratios, ARIA attributes and form labels, heading hierarchy and alt text. It is able to label all of those things. So what you can do is run it 3-4 times actually, average scores, and use incognito mode, fix the red and orange issues first. Now we come to your fourth pillar, which is your keyboard testing. So it's a let's do like a reality check. So the challenge is, maybe we can do a small exercise. So maybe unplug your mouse, or if you are working on a laptop, just switch off your mouse pad and navigate your entire site with tab, shift tab, enter space, escape, and arrow keys. Just try to do that. Take 5 minutes, maybe pause the video, and take that 5 minutes, turn off, unplug your mouse, turn off your laptop's finger pad, and try to navigate this website with just tab, shift tab, enter, and come back to this video on the same timestamp. You can pause the video and I'll still continue. So let us continue. I hope you did experience something, you did try to do it, and I'm sure you might have come across some issues. So one is invisible focus. It is very difficult to understand that where I am if you are navigating a website with tab. I can't see where the cursor at the given moment is, right? Then there's a keyboard trap. So if I am stuck in this model, I cannot escape. So if there is a drop down, or if there is, you go inside a particular dashboard, then it is very difficult to come out. Then wrong tab order. So why did the focus jump from header to footer? I don't know. Or missing keyboard support. So this drop down works with mouse but not keyboard. So the statistics says that there are millions of people who navigate web only through keyboard. And I mean, we have stats from some reports from America, but I'm sure there are stats from India as well. So to tool the accessibility inside shows visual tab order overlay. So once you try to navigate it with just the keyboard, you will be able to pinpoint all of these issues a little bit better. What we have to do is many a times also, the keyboard tab architecture may be different from your visual architecture. And again, I would refer you back to the book, which is called Mobile Accessibility Rituals. Then if you are talking particularly about mobile apps and app design, then mobile accessibility scanner, which is again your inbuilt system, is something which is most people kind of overlook, primarily because it is there already on your phone. So it's an accessibility scanner. It's a free Google app. You can just install it from Play Store, enable floating action button overlay, navigate your app site, tap scan, and you get instant results. So there can be some challenges which are unique to Android. So minimum touch target has to be a 48 by 48 dp. Talkback gestures, so swipe to navigate and all of those things are there, because you cannot the system kind of relies on the fact that you're not able to visually interact with the screen. So you have to have certain gestures to navigate. So instead of tab, it's actually a swipe on the talkback for the next word to be announced, the next button or whatever the action. So in the keyboard interaction is tap, tap, tap. But in your mobile interaction is swipe, swipe. So maybe you can pause the video here as well, and take 5 minutes. You take your phone and you turn the accessibility scanner. Just download this app, accessibility scanner app, install it on your phone and run it, and try to navigate any of your favorite app, and just try to understand how it works. How it handles screen rotation is also very unique. Device fragmentation around different manufacturers. So emulators miss the real bugs, so test on real devices. So many a times while we are developing, we are developing on actual PCs, and we are developing the application and testing them in an emulator, right? Developing them in an emulator, and so but testing them on the emulator may not be the right way to do. Rather, you kind of export an APK, install it on your phone, and then test with your accessibility scanner app. So things which it is able to find is touch targets. It is able to identify if it is too small for fingers. Low contrast text, it is able to pinpoint. Missing labels on interactive elements, it is able to pinpoint. Clickable items are too close together, maybe. All of those things it is able to identify. So recording mode, test entire user flow, not just single screens. Okay, and the gap may be that 60% mobile traffic and 20% testing effort is required. So what it means is that if you are able to put in your 20% effort, that may increase your mobile traffic by 60%. So please put in that effort. Then we come to the iOS accessibility testing. So there's something called the Xcode accessibility inspector. So you have to have a Mac and Xcode. Then if you have a Mac, then Xcode is free. What it tests is voiceover, announcement, element labels and traits, as well as focus order. So when you press tab or when you do swipe, what is the order in which it is appearing? How to access? So Xcode, open developer tool, you open Xcode, you open developer tool, you go to accessibility inspector and then just run your app. So it is able to identify minimum touch target. The voiceover gestures are swipe based. Safari and voiceover required as a combo. And 70% of the blind iOS users rely only on voiceover as their talkback, as their screen reader. So I'm sure we are also recording a tutorial where we'll be talking about the mobile scanning app. So one is your this accessibility scanner of the Android, as well as your Xcode accessibility inspector of the iOS. And we will be talking about both of these mobile accessibility scanning applications through more of a tutorial format, and you can see those sessions as well. Here in this session, I am trying to kind of give you an idea of all what is existing and where, in which situations you can use which tool. So now let us talk about the ARIA labels and ARIA coding. So when you when your fix breaks everything, right? So for example, some common disasters. So in your HTML code, if your screen reader says submit button. So here what is happening is that you've already labeled a button, ARIA label equals to submit button, and then it says submit / button. So it's reading all of those together, and then the screen reader reads submit button. So you just use the semantic HTML labeling first. The other disaster can be ARIA hidden true in button, then it's buy now, looks perfect. The screen reader button does not exist because you have not for the screen reader you have not added the ARIA button label. Then here in this kind of scenario, it says it's a button, doesn't work like a button, right? So the right way is button, click me, button. So the number one source of accessibility bugs is misuse of these ARIA labels, and it is just important to understand and inform yourself about how to use. So I mean, it actually there is an official W3C rule which says no ARIA is better than bad ARIA. Now let us come to some other aspects. So we did talk about specialized analyzers in the beginning of this session, and now we have kind of moved across all of those different kinds of accessibility evaluator tools. Now we will talk about your color analyzer tools, for example. So WCAG minimums are, for different kind of text, different kind of, for WCAG, the minimum thresholds for contrast have been defined. For normal text, it is 4.5:1 or 7:1 if it's a AAA compliance. For large text, it is 3:1, and for UI components also, it's a minimum of 3:1. So your specialized tools, for example, so here it says, so see normal text, this is a normal text, so it has to be 4.5:1. Larger text, it can be lesser. For bold text also it can be lesser. For icons, it can be 3:1, and for UI elements like a button, it has to be 3:1. Now, so what we are here doing is button against the background. So button contrast. So UI elements means the border, icon, underline, and the context. So if the button contrast against the background is 4.1:1, here it is passing. Here the text is also text against the background, white on teal, it's passing. Here teal on grey, it's passing, 4.5:1. Here it is, in order to increase the contrast, what we have done is we have used navy text and neon blue button background. So here the ratio has largely increased, so it's very, very tightly visible, right? But here what is happening is that the button to background ratio, this teal against this background, is decreased. So it is now 1.1:1, which is now failing. So now we have to see that how we can use all of this information in the best way possible. So maybe we increase the button, the text size. That will also involve increasing the button size a bit. And we are saying, okay, the text is now 24 point plus. So now our minimum limit is 3:1, and now we put white on green, and this green against gray is also 3:1. So we are passing in both formats. So what tool? This color contrast analyzer, which is also a free software. It has eyedroppers where you pick colors, and it tells you instant pass or fail. So you pick two combinations. So I pick this and this, it will tell me instantly whether it's a ratio pass or fail. So real student mistakes. So for example, designer picks number hash number 777 gray on white ratio. 4.47:1 barely passes, hard to read. Better, another type of gray, which is a darker gray, ratio is much higher, everyone can read comfortably. So also you have to see that it's not barely passing, right? If it is 4.5, 4.5 is given and it is 4.47, then it is not really passing. Built-in browser checks. So Chrome DevTools inspect, you can open that, and then you can put go to inspect text, and you can see the contrast ratios live on your Chrome built-in browser check. The impact is that good contrast is equal to legal compliance, better user experience for millions of people with low vision. We have not even talked about low vision users, because we are so engrossed with, say, sensory impairment. But there are millions, much more millions of people who have low vision or color blindness for that matter. So that is why it's 4.5:1 is a law, and it's not really a suggestion. So we have to comply with this law. So color contrast, how it is through. So in a AAA level, at the top level, the regular text at 16px has to be 7:1. So this is an example of what 7:1 looks like. This is also an example of 7:1. At AA, it is 4.5:1 against this background. So if you're seeing, we are changing the background saturation. The text is all white. And that is what is changing the ratio. 3:1 is actually non-compliant for regular text. If it is bold or if it is icon or if it is more than 24, then you can use 3:1. So please remember this. Then millions of people see colors differently, so they are color blind. So there are like some very eye-opening statistics around color blindness, which is like 8% of the males globally have color blindness, and 300 million people globally have color blindness. So maybe you can just check it right away. Here it's an image from the Ishihara test. You can take that test also. You can just Google it, the Ishihara test. This is one of the image. So just guess what number you are able to see. If you are able to see 74, probably you are not colorblind. But if you are not able to see, I would suggest please take the Ishihara test and you will get to know if you have color blindness or not. And the point is that as developers, we have to ensure that all our users and not so many millions of people get excluded because of incorrect use of colors, right? So common failures, which is so largely most common kind of color blindness is red-green color blindness. So for example, here the background here is red and there is a number written with green dots, which is 74. If you are able to see it, great. If you're not able to see it, that's fine too. It's a very common disability, but I think that kind of opens your eyes towards how common is it. Right? And then red-green indicator. So success is green, error is red. Colorblind users, they all look the same. So if you have, all of these dots which says, red color is that something is going fine and the error says red and just small dots or some text appears. For a colorblind user, it looks the same. Or if you say, color, so I'm sure, this very great example of this situation. Earlier, this is a recent example. So I'm sure you might have all seen those veg and non-veg dots which used to appear on all edible packaging. So earlier it was, both of them were dots and they were just different colored dots, green and red. But if for a colorblind user, both they look the same. So how would they differentiate between veg and non-veg? So eventually it was then changed to color as well as differentiation of shape. So now veg is like a green dot and non-veg is a red triangle. So even if you're colorblind, you can rely on the shape differentiation. So for example, another common failure can be you click the blue button and there are 4 buttons which are different color, same size, same shape, no signifier, or signifier is the text which is written. There's no text written and you just mention whether you press the blue button. But which is the blue button for a colorblind person, it may be difficult to identify. Then there may be charts with no labeling or just colors, then that becomes almost unusable. So again, testing tools can be your DAVE tool, rendering, emulate vision deficiency. So there is this drop down already. So if you go to rendering and you select emulate vision deficiencies, it will give you a short report. Then Figma plugin, Stark is a commonly used plugin. Then there is another app called Color Oracle, which can help you in identifying color blindness related issues on your product. So the fix is almost always never use color alone. Use icons, use verbal labels, or use patterns as well, like dots and stripes also, if it's like areas of colors. So after all of this, we have come to the point that a complete testing strategy would be to use all of these tools in combination. So you in phase 1, you use automated scan, you use Lighthouse, you use Axe Dev tools, you use Wave, and find out the technical violation. In phase 2, you do your screen reader testing, your keyboard testing, all of this manual testing, which finds out your usability barriers. Then in phase 3, you do your user testing with real people with disabilities, then which may take 1 week of time. So most teams, they run automated tools and then ship. So but in that scenario, you are only getting access, or you're getting to know about only 30% of the problems, and you're missing out on the remaining 70. But accessible teams, they automate, they use automated tools, they use manual tools, they use user testing, and then they are able to find out all the 100% of the accessibility issues. So the final launch product is likely to be more accessible than the one where we are not employing all of these steps. So tools can only enable, facilitate accessibility, identification, but humans have to ensure it. And this is where we like to close today's session. There's a lot of these tools which we have spoken about, and I have added the link to all of them. You can go through at your own end, and if you have questions, we can answer them on the forum as well. And we have recorded one tutorial on the Wave and the Lighthouse tools, which are your web-based tools, and we've also be publishing another tutorial on the mobile accessibility evaluation tools, which is your VoiceOver and TalkBack. And I hope you get access those tutorials as well. And meanwhile, please turn on all of these free tools. Please install them on your laptops, please install them on your phones, and explore these tools, and a lot of it you will be able to identify and get a hang of yourself, I'm sure. So happy exploring, and let's make products more accessible, and please transfer this knowledge to your colleagues at work as well. Thank you for joining today's session. I will see you in the next